talk about the conservation of mechanical energy principle. What does it say? Conservation of mechanical energy principle, it says, suppose we have a single body or multiple body system which is not interacting with its surroundings, is an isolated system, and there are not any dissipative forces like friction, etc., then it says that sum total of potential energy and kinetic energy is going to remain constant. Conserved means constant. It is going to remain constant. That is, sum total of the potential energy and kinetic energy of its various constituents is going to remain fixed. It is something like I have 2 or 3 pockets and I am carrying some currency, I am carrying some money in a upper pocket. I have the lower pockets of my trousers, they are empty. So after, let's say, I moved some distance, I put few bucks from here and put it over here. So what I have done is, I have changed the potential energy or kinetic energy of one block and I have given it to some other pocket or to some other block. But still, I as a system am carrying the same amount of money, I am carrying the same amount of energy. It is the same thing when we talk about the isolated system. It may be exchanging energy within itself, potential plus kinetic energy, but the total energy it is carrying is going to be constant. Let's say this is our reference level. This is reference level, and from here to here, this is the height. We have taken 3 positions. One is, this position is A, this is position B, and C is on the reference level itself, this is C. And let's say the body of mass m has been released from here. It has been released from here. And this distance is, suppose, x. If this from here to here it is x, so then obviously from here to here is h minus x. So our intention is to find the potential energy at, so now our intention is to find the mechanical energy at A, position B and position C, and then we will see, that is, whether the mechanical energy at A, B and C position that remains same or not. Let's do it. So mechanical energy at A is obviously potential energy at A plus kinetic energy at A. What is potential energy at A? This is going to mg. What is h? H from this reference level. It is h plus what is kinetic energy? Half m 0 square, because it has been released from here. So velocity is 0. So mechanical energy at A is going to be mgh only. Now let's take position B. When the body has gone from here to here, the force which was acting on it, it was mg. Force is equal to mass into acceleration. So it is accelerating obviously with A value only. That is, A is equal to g only. That is action due to gravity. So when we talk the position B, we say v square minus u square is equal to 2as. We are at position over here. We don't know. Minus u square. U is where? It is over here. We are taking the instance from here to here. Velocity, initial velocity over here is 0. We have done it in kinematics. 2a is what? G. What is this? This is s distance. What is this? X. So v square is equal to 2gx. So now let's find out mechanical energy at position B. So at position B, it is going to be potential energy at B plus kinetic energy at B. What is potential energy B? That is mg h. H is what? This height is always from the reference level. You cannot change the reference level in the middle of the question. Once the reference level has been chosen, till you are able to solve the whole question, you cannot change the reference level. So it is mg, this is going to be h minus x, plus kinetic energy B. What is kinetic energy B? Half m velocity over here. What is velocity over here? We have just calculated 2gx. Half m, and this was v square only. So it is, we don't have to square it again. So this is going to be mgh minus mgx, and this is going to be what? 2 and 2 get cancelled, plus mgx. So that comes out to be mgh. So that is mechanical energy at B, it comes out to be mgh. This comes out to be same only. That is what was mechanical energy at A. And the mechanical energy at C, and eventually this will come out to same only. That is potential energy at C plus kinetic at C. What is potential to C? That is mgh. The body is here only. Reference, this is a point mass body. It doesn't have any dimensions. So mgh, h is going to be 0 plus half m. Now we have to say vc square. What is the velocity over here? So let's take the journey from here to here. So vc square minus u square, we are taking from here to here. Velocity over here is vc. Let's write it vc minus 0 square is equal to 2, A is G and this is H. So Vc square is equal to 2gh, that is velocity over here just before striking the ground. It is not the velocity after striking the ground, that will also become equal to 0. But this is when we say velocity, it is velocity just before striking the ground. So it is half mv square. So mechanical energy at C is equal to, this comes out to be 0 plus half Vc square is what? 2gh, 2 and 2 get cancelled, so it is mgh. So mechanical energy at C comes out to be mgh. It comes out to be equal to what is total mechanical energy at B position. It comes out total mechanical energy which is at position number A. This is something what we mean by conservation of mechanical energy principle. That is, sum total of mechanical energy of the whole system remains constant. Over here we have just taken a single body system, though when you talk of the gravitational potential energy, it is primarily of the block and the earth, but we take the cases like we take the blocks etc. and we find the gravitational potential energy of such systems because this is a gravitational field is a conservative force, this is a conservative field. We will come to that later on. And over here we have seen, this way we have seen, if there is a single block system, we have seen that is mechanical energy of this body remains same. It is only the interaction, that is, it's only the transformation when it is coming from here to here. Over here the whole energy, it was potential energy. When it comes over here, the potential energy is lost. So over here it has some potential energy, it has some kinetic energy. When it comes over here, the whole potential energy has converted into kinetic energy. Over here the potential energy of the body is 0. All energy is in the form of kinetic energy. Over here also energy is in terms of joule, joule and joule. Unit of energy is joule. It is a scalar quantity. You can algebraically add and subtract. Whereas when they are vectors, you cannot directly add or subtract.